All right, listen to these very important instructions. What you're going to write on your notes is not going to be the same thing as what I write in the notes. What I want you to do first here is in this little section down here, just very quickly pause the video and write down how the graph to the right here represents the solutions to x is greater than 3, and how does the graph represent the non-solutions to x is greater than 3. Go ahead and write down your thoughts on those. Pause the video, do that, and then come back. All right, welcome back. You should have some full sentences written here. I'm not going to be doing the same writing. I am going to talk about what kind of things we should have written about. Hopefully what we talked about is the fact that the graph shows us where what values are solutions to this inequality by having them in this shaded region, right? The shaded region of this graph is where we see solutions. The non-solutions are the things in the non-shaded region. Non-shaded, non-solutions. You'll notice, and you may have talked about, that boundary value that separates the non-solutions from the solutions. In this case, the graph represents that point, that value 3, is a non-solution by having it be an open boundary as opposed to a closed boundary, an open bullet instead of a closed bullet. Just one last piece, we can see that these things are solutions because when we replace x with those values, we get true statements, right? 5 is greater than 3. 6 is greater than 3. Those are true statements. Whereas if we were to take the non-solutions, we would get false statements. So again, what you wrote shouldn't be this. You should have sentences here, although you may have also written some examples. Right? Next quick write, I'm going to ask you to tell me how this graph represents the solutions and the non-solutions to this equation 3x minus 5y is equal to 12. Go ahead and pause the video and write your thoughts on that topic. All right, welcome back from your pause. At this point, you should have a whole bunch of stuff written in here about how solutions are the values that make the equation true, and the points on this line, points like, boy, which points are on this line? How about a point like -1, -3, -1, -3, that those values that are on the line are solutions. The way that this graph represents the solutions is by effectively shading the line where all the solutions are. So for example, 3x minus 5y equals 12, when x and y are equal to -1 and -3, we have 3 times -1 minus 3 times -3, which is 5 times -3, -3 plus 15, which is 12. That converts this open statement into a true statement, right? Equals 12 equals 12. All of the values, including all the weird little decimal values that we can't name, will do that same thing. If, on the other hand, we look at any value that's not on that shaded in, that solid boundary, anything up here, anything down here, all of those other values will make this equation false. So a value like, we'll say 3, 2, right? For the equation 3x minus 5y is equal to 12, 3 times 3 minus 5 times 2, right? This is going to be 9 minus 10, which is -1. Now we've turned this equation from an open statement to a false statement. Right? The way that the graph shows us which things are solutions, which things will make the equation true, is by effectively putting ink or putting pencil lead or putting line or shading wherever we're trying to indicate we find values that make the equation true.